Hello, students. I am Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structures, that is bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in wrong order. This process continues until no swaps are needed, indicating that the list is sorted. In order to have a better understanding of bubble sort, let us take an example in which we have five elements in the array and they are unsorted and we have to sort them, suppose, in increasing order. Suppose the values stored in the array are 140, 90, 80, 40, and 30. So in order to perform bubble sort, in the first iteration, In the first iteration, we will start by comparing the first element with the second element. If the value stored at the zeroth index, that is the first element, is greater than the second element, then we have to swap these two elements. That means the array will now store the values as 90, 140, 80, 40, and 30. In the next step, we will compare the next two elements, that is the elements stored at the index 1 and index 2. Again, as we can see that first element is greater than the second element, that is 140 is greater than 80. Again, we have to swap these values. So after swapping, the state of the array will be 90, 80, 140, 40, and 30. In the next step, again, we will compare the next two elements, thereby comparing 140 with 40. Again, the first element, as you can see, is greater than the next element. We have to swap them. And after swapping, the state of the array will be 90, 80, 40, 140, and 30. Again, we have to check the next two elements. And as you can see, again, the first element 140 is greater than the next element, that is 30. We have to again swap it. So as you can see that after this swapping, the state of the array will be 90, 80, 40, 30, and 140. Therefore, the largest element of the array has got its appropriate position. So you can see that after one iteration, one of the element of the array has got its appropriate position. Now coming on to the next iteration, the values stored in the array were 90, 80, 40, 30, and 140. So in order to perform the next iteration, again you have to start by comparing the first element with the second element, that is the element stored at index 0 with the element stored at index 1. So when you will compare these two elements, you can see that again 90 is having a value which is greater than its next element. So we have to again perform the same operation and we have to swap them. So 80 will become the first element, then we will have 90, then 40, then 30, and 140 is at its appropriate position, right? Then again, we have to compare the next two elements, and as you can see that 90 is greater than 40, so again, we will swap these two elements. So after this swapping, the state of the array will be 80, 40, 90, 30, and 140. Now again, we have to check and see for the next two elements. And as you can see that again 90 is greater than its adjacent element. So we have to swap them, right? So after swapping, you can see that the state of the array will be 80, 40, 30, 90, and 140. So as you can see that there is no need of comparing 90 with 140 because 140 was already fixed in the previous iteration. So here you can see that the second largest element 90 has got its appropriate position. So this is iteration 2 in which the second largest element has got its appropriate position. Now coming on to the next iteration, that is iteration number 3. As you can see that the state of the array was 80, 40, 30, 90, and 140, in which 90 and 140 have got their appropriate positions. Again, we will start by comparing the first two elements. Now, as 80 is greater than 40, we have to swap these two elements. And after swapping, we will get the state of the array as 40, 80, 30, 90, and 140. Again, after comparing the next two elements, that is 80 with 30, we need to swap these two values. And so the state of the array will become 40, 30, 80, 90, and 140. Now, as you can see, there is no need of comparing 80 with the next element because 90 was already fixed. And 120, 140 was also already fixed. So as you can see that in iteration third, 80 has now got its appropriate position. Now, coming on to the next iteration, again we have to start by comparing the first element with the second element. So the state of the array was 40, 30, 80, 90, and 140. These three elements are already fixed and there was no need of comparing these elements now. The only requirement is to compare the first element with the second element. And as you can see that first element is greater than the second element. Again, we will swap these two elements, thereby making the state of the array as 30, 40, 80, 90, and 140. So as you can see that if the value of n was 5, that means the number of elements in the array were 5, then in order to sort the entire array, we needed n minus 1 iterations. The number of iterations required were n minus 1. In this case, the value of n was 5 and we have successfully sorted the entire array in 4 iterations. Let us now see the algorithm of this sorting technique. So the function bubble sort will have two parameters, including the array that need to be sorted and the number of elements that are stored in the array, which is here denoted by n. So as you can see that for n elements, there were n minus 1 iterations that were required. So the first loop will start from 1 and it can go till n minus 1, right? So here the outer loop indicates the iterations which starts with I is equals to 1 till n minus 1. Now, as you can see that in every iteration, we have to repeatedly compare the adjacent elements. So we are comparing aj with aj plus 1. And for this, the value of j, in the first iteration, the value of j must go from the first element till the second last element, right? from the first element till the second last element. That means it should go from 1 to n minus 1. And as you can see that we are comparing aj with aj plus 1, we will successfully compare the second last element with the last element. In the next iteration, you can see that it was not required to compare the last element because it was already fixed. So in the next iteration, we need to compare the elements starting with 1 to n minus 2. And again, in the next iteration, we will be comparing the elements from 1 to n minus 3. So in this way, the upper bound of the loop is decreasing. In order to implement this, we can simply give the inner loop as j is equals to 1 to n minus I. As the value of I will keep on increasing from the outer loop, in the inner loop, the value of n minus I will keep on decreasing. And inside these two loops, we have to compare, every time we have to compare aj with aj plus 1. Value of aj is greater than aj plus 1, and we have to swap these two values. Now, how to derive the complexity of this algorithm? As you can see that in the first iteration, there were n minus 1 comparisons. In the next iteration, there were n minus 2 comparisons. And in the next iteration, there were n minus 3 comparisons and so on. And in the last iteration, there was only one comparison. So we can say that in order to derive the time complexity, if we add all these number of comparisons that we are doing, we can have the value as n into n minus 1 by 2. As you can see, this is one of the AP series, and the sum of the series will come out to be n into n minus 1 by 2, which is nothing but n square by 2 minus n by 2. And this function, as you can see, can be represented with the help of asymptotic notations. And as the highest order of n is 2, so this can be given as O n square. So this is definitely going to be the worst case in which every element is being compared with the adjacent element, and we are considering that the values which we have got are totally in opposite order. Suppose we want to sort the elements in ascending order and we have got the values in descending order. Then the number of comparisons will be n into n minus 1 by 2, and hence the complexity, the time complexity will be O n square. But what if we get the values which are already sorted? See, suppose we have the values. Suppose we take an example in which the values stored in the array are already in sorted order. Suppose we have the values 10, 20, 30, 40, and 50. So you can see that when we will compare the first two elements, no swapping is required, right? Because the first element is greater than the second element. So the state of the array will remain same. 10, 20, 30, 40, and 50. Now again, if we will compare the next two elements, there's no need of swapping. There's no need of swapping again. And the state of the array will remain same. The values will be same. 10, 20, 30, 40, and 50. Again, comparing the next two elements, again, when we compare the next two elements, again, there is no need of swapping. And so the values of the array will remain same. That is 10, 20, 30, 40, and 50. And again, when we will compare the last two elements, there is no need of swapping. That is, the state of the array again will remain same. 10, 20, 30, 40, and 50. So in this way, we can say that if in any of the iteration there is no swapping done, then there's no need of further checking in the next iterations, right? So how can we optimize this algorithm so that if in one iteration the array is already sorted, then there is no need to move on to the further iterations. So in order to do so, we can take another variable and we can store the true or false into it. And if we are not getting any swap, then the state of the flag will remain same. And if we are swapping any values, then the state of the flag can be reversed. So this algorithm can be modified in this way. The number of iterations will still go from 1 to n minus 1, but we have taken a variable flag and we have stored a false into it. And in the inner loop, if any time the value of aj is greater than the value of aj plus 1, and we are swapping the value of aj and aj plus 1, then in that case, we are reversing the state of the flag and we are setting it to be true. So what we can do? After this for loop, we can check the state of flag. If the state of flag is still false, that means none of the swapping has been performed. Because every time the first element was smaller than its adjacent element, right? Only in that case, no swapping will be performed. And therefore, the array is already sorted. So we can simply check that whether the value stored inside the flag is false or not. If it is still false, we can simply come out of the outer loop by using this break keyword. So if we compare this algorithm and if we see the total number of steps that will be performed by this algorithm in the best case where the array is already sorted. So you can see that the time complexity that we can derive with this algorithm, in the best case, there will be only n minus 1 comparisons. And so in this case, the complexity can be written as omega n. This is the best case complexity of the bubble sort, that is omega n. Now, if we talk about the space complexity, then we can see that the only extra variables that are required are I. And if we can see here in the optimized algorithm, we have taken a false flag, then we have taken a j, and we may require another variable to swap the values of aj and aj plus 1. So we can see that only 4 variables are required. So we can say that the space complexity is constant and it can be represented by theta 1. So these are the complexities. The average case complexity of bubble sort is theta n square. The best case complexity of the optimized algorithm is omega n. And the worst case complexity is big O n square, while the space complexity of the algorithm is theta 1. Now let us try to implement this code with the help of C language. In order to do so, first of all, let us include the header file. Let us make a user-defined function, bubble sort, and we have to pass two parameters, that is array and the number of elements as the parameters. Now, in the bubble sort algorithm, we have to implement two loops. The value of I will start from 0 and the value of I will go till less than n minus 1, because here we are implementing. So the values will start from 0 and it will go till the second last element. So this will go till less than n minus 1. Coming on to the inner loop, for int j is equals to 0 to j is less than n minus I. Again, we have to minus 1 this value as we are implementing, and the indexes will start from 0, j plus plus. Inside this loop, we will check whether the value of ARR j is greater than ARR j plus 1. If it is so, then we have to swap these values. And in order to swap, we can take a temporary variable here. And we can write temp is equals to ARR j. ARR j is equals to ARR j plus 1. And ARR j plus 1 is equals to 10. These are the steps to swap the values. Coming on to the main function, we can take one array and we can initialize it with some values. We can take any random values. Suppose I have taken these 5 values, and then we can take n as the number of elements, and we can anytime calculate the number of elements by dividing the size of ARR by the size of single element ARR 0. And then we have to call the bubble sort function with the array and n. And afterwards, we can display our answer by putting a loop starting with 0 to n minus 1 and calling the printf function. Now, as you can see, the values are already sorted. So we have got the answer as 27, 30, 87, 89, and 120. The references taken for this video are Tenenbaum and Langswam and Augustine, Data Structures Using C, Horowitz and Sahani, Fundamentals of Data Structures, Shom series, Data Structures, and Thereja, Data Structure Using C. Thank you.